All right, so let's do some examples in the study of probability, right? Now, last class we have done the introduction to probability, so let's try to solve some examples here, right? So let me say number one, um, what what is the possible outcome of a coin, a coins, or what is the possible outcome of throwing a coins? So a coins. Now you know if I have a coins, that's one coins, right? For one coins, what is it? I didn't say what's the probability. I asked her what's the possible outcome? That is the sample space of our probability, right? So we know that a coin has two things, head and a tail, right? So the sample space of a coin is what there is head and tail. So what is the total possible outcome of a coin? That's head and tail. That's one coin. What if I'm asked to find for two coins? What will it be? For two coins here, I'll use the idea of tree diagram to explain this. And I also use another alternative to explain this. Now, if I'm to use tree diagrams, so using tree diagram, right? So don't be scared. This is my first time mentioning tree diagram, Abi. Just hold on, just watch. Now, except for two coins. For one coins, for our first coins, I'll have what? Head and tail. I'll have head and tail. This for one coins. One coins gives you head and tail. Now, for two coins, what will it be? Now, for two coin, here's this place. If I throw, I will assume this one is one coin now. If I throw this one coin, I'll have a head and another tail. I will assume this is another coin. If I throw the coin, I'll have what? An head and what there? And a tail. I see this place. One coin gives you head and tail. For two coin, here's how you do it. Go back to this. Assume this to be one coin. Now, for one coin gives head and tail. For one coin, it gives head and tail. This for two coin. And what will be the sample space? So the sample space here, the sample space, perhaps I can use S to represent it. Yeah, S. Um, S is equal to what? What's sample space for two coin? Now, here's how you do it. Head and head. Observe please. Head and head, comma. Head and tail, comma. Tail and head, comma. Tail and head. All right. So head and head. The first outcome is head and head, comma. What's next there? Head and tail, comma. What's next there? Tail and head, comma. Sorry. Yes, tail. Tail and tail. Tail and tail. So for two coin, the total outcome of two coin is what? Is 4. 1, 2, 3, 4 is 4. Total outcome for one coin is 2. Total outcome for two coin is what there? Is 4. Now, this is tree diagram pattern. If I don't want to use tree diagrams, let me show you one way to do it. You know, for one coin is, I'm asked to find for two coin, right? Another way to do it is this. For two coin, another way to do it is this. Let's say head and tail is for one coin, right? Another head and tail. This is now one coin, two coin. Now, I will now do this way. Head and head. This gives you head and head. Head and tail. Here gives you head and tail. Tail and head. That gives you tail and head. Then tail and tail. Tail and tail. If you observe please. Head and head. Head and head. Head and tail. Head and tail. Tail and head. Tail and head. Tail and tail. So I have what there? A 4. See, 1, 2, 3, 4. 4 sample space for two coins. This is another method of doing this instead of using tree diagram, right? So this is another way of getting the possible outcome of two coin. What for three coin? What will it be? What will be three coin? What will be for three coin? Let's go for 3 coin. For 3 coin, let's see what will be. And you take assignments for me. Do 4 coin for me. And leave your answer in the comment section. Let's do for 3 coin. What will it be? For 3 coin, what will it be? So let's say I have 3 coin. Now for 3 coin, we said our first coin has head and tail. Second coin will have, we said this goes like this: head and tail, head and tail. Hold on, I'll come down a bit. Head and tail. This is for second coin. Now for third coin, it's simple as take this as 1 coin. So 1 coin gives you head and tail. This one gives you head and tail. This one gives you head and tail. This one gives you head and tail. This is how you work with this. For 4 coin, same thing. This one gives you head and tail like that. This is how it works. This is how the tree diagram works. Now, what is the sample space for 3 coin, or the total possible outcome of 3 coin? So the sample space for 3 coin is given by this. Look what this means. Head, 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 that's 1. Head, head, tail, that's 2. Head, tail, head, head, tail, tail. Observe please. Oh, head, head, head. So the first one, head, head, head. This one is done. What's next there? Head, head, tail. Next up, head, head, tail, comma. Head, 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 tail. What's next there? Head, tail, head, head, tail, tail. Have head, tail, head, head, tail, tail. Head, tail, head, head, tail, head, head, tail, tail. Next up there, tail, head, head, tail, tail, tail. Observe please. Sorry. Observe. Tail, head, head, tail, head, tail. Tail, head, head, then tail, head, tail. So tail, head, head, tail, head, head. Observe. Tail, head, head, then this tail, head, tail. Tail, head, tail, comma. What again? Tail, tail, head, tail, tail, tail. Alright. Tail, tail, head, tail, tail, tail. Alright. This is my sample space for 3 coins. So that's 1, 2, 3, 4, 5, 6, 7, 8. So a 3 coin has a sample space of what there. The sample space, it means we know what sample space is now. So that's 8. For 3 coin, for 2 coins, that's 4. For 1 coin, that's 2. So you do for 4 coin for me and leave your answer in the comment section. So let's say for instance now I want to apply this other way around, this one, this tabular form to get this one. What will it be? Tabular form is this. We'll be comparing 2 coin and 1 coin together. For 2 coin, what's the outcome? I have head, head. I have head, tail. I have tail, head, and I have tail, tail. This for 2. With on that one here, head and tail. That makes it 3, right? 3 coin. This for 2 outcome, then 1. That's 3 coin. Now head. This one gives you these 2 head, and this one gives you head, head, head. That's 1. This and this gives you head, head, tail. This and this gives you head, tail, head. This and this gives you head, tail, tail, head, tail, tail. Right? Watch again. This one gives you tail, tail, head, head. This one gives you tail, head, tail. Mention this one first. We have tail, tail, head, and we have tail, tail, tail. You can see the same thing. 1, 2, 3, 4, 5, 6, 7, 8. The same thing that is here. So this is like tabular form of getting this stuff, and the tree diagram concept of getting the outcomes of this. So this is like what I want to just know when it comes to coins case, right? Just watch, understand this, please. Let's not do other examples, please. Example 1 is done. Let's move on to other example, please. Example 2, please. It says, in a family of two sons and a daughter, the parents wish to sponsor one wish to sponsor only one of the children. What is the probability of sponsoring a boy? Now, whenever you read out a question in probability, your task is this: write out what you are given. In this question, I'm given both son and daughter, that is boy and girl, right? So in a case like this, there your first priority there is that I am given boys, that's son. How many are there in the family? There are two boys. For the girls daughter, how many are they? They are just one, right? So after listening out what is in that question itself like this, your first task is to get what? The sample space. Now the sample space here is what? Is three, sorry, is what? 2 plus 1, and that's what that's 3. So in the family, their total of children they have there is 3. 2 boys and 1 girl. That's sample space. All possible outcome, right? So 2 plus 1 is 3. So your first task get what? Their sample space. But hold on, oh, we are asked to find what? We are asked to find what there? The probability of sponsoring a boy. Now it means that I will now come here, question A. The probability of sponsoring, what's the event here? Boy. That's boy. A boy. And this is equal to, we said probability of sponsoring a boy will be equal to what there? So, all possible outcome of that event. The event here is boy. So all possible outcome of boy is what? Is 2. All possible outcome of boy is 2. All over what there? Total outcome, or I call it what? Sample space. And that's what there? And that's 3. In other words, the probability of sponsoring a boy in that family will be equal to 3 over 2 over 3, or better still, calculator, 2 over 3 gives you 0.6 6 and 6 like that, right? It continues, right? More of like saying 66% chance, right, of sponsoring a boy. That's for a boy, right? This is what we have to find. That's all basically is done. But here's on that week, what of if we are asked to find the probability of sponsoring a girl? So it means that the probability of sponsoring a girl, for a girl, what will it be? We said all possible outcome of that event, that is all possible outcome of a boy, of a girl. For girl is 1, just 1 over, we said total outcome, or perhaps sample space, and that's 3. That's 3. So for girl is 1 over 3, and 1 over 3 is equal, likely to be equal to 0.1 divided by 3. That gives you 0.33, and it continues 3333333. This is how you solve probability, as simple as this, please. That's all. Now there is one thing I forgot to give you, and I'll give you now. Please see, in your note, draw a line like this. Not in your note, you have lines. So make 3 lines and write this out to give you inside. Literally, let like whenever you open your book, this part it should be shining. Like it should be seen like, there's something here. Yes. Use a red pen to line it this way. And use a blue red, just make sure you write that thing, anything you write here. Whenever you open your book to read, it should be obvious that something is written here. It should be shining, because what I'm about to give you is something important. When you lose out on it, you have failed probability. What is that thing? Please note. Please note. Please note, please. Your answer or solution, your answer or solution must be from 0 to 1. Your answer or solution must be from 0 to 1, comma. If it is less than or greater than, if it is less than or greater than, it means your workings is wrong. It means your workings is wrong. Okay, what are we saying? Here's the English I'm saying. Whenever you solve any question on probability and your answer is above 1, let's say 1.0, sorry, let's say 1.1, 1.2, you are wrong. In probability, you don't get more than 1. You only get 1 and below 1. Now, your answer must be within 0 and 1. If you have -1 as your answer, you are wrong. Probability, your answer must be from 0 to 1. No more than 1 and no less than 0. Must be within the range of what? 0 and 1. You can see my first answer, 0.66. It's still at 0, within 0 and 1. My answer here was what? 0.33. It's still within the range of what? 0 and 1. So all your answer and probability must be within 0 and 1. 0 and 1, please. Alright, that's what I want you to note. Now, let me now show you one tweak before I move on to that question again. You see, in this question we have here, this is our question here. The only thing I'm having here is boys and girls, right? Let's say let's assume that they add father, mother, grandmother on that case. But in this case, it's just what? Boy and girl alone. So if I have we are asked to find only for boy, but I went ahead to show you for girl, right? Now, in this probability, we have only boy and girl. No brother, no sister, no uncle, no grandma, no. It's only boy and girl that we have here, Abi. Now, if we have only boy and girl, the task is this. For every question probability, if you find all the possible given objects there, like here is boy and girl, we'll find the two of them. If I sum the answer of all probability of the event given, for instance, if I sum up the probability of boy plus the probability of girl, aside these two, nothing else again, my answer should be 1. So I'm saying this, if you solve probability of all the events in a question, the answer must be 1. How? Let me show you. Probability of boy is what? 2 over 3. That's 2 over 3. Plus probability of girl is what? 1 over 3. 1 over 3. This man gives you 2 plus 1. That's 2 plus 1 over 3 and 3 are the same thing. Just put 3 here. This man gives 2 plus 1 gives you 3 over 3. 3 here 1, 3 here 1. What's my answer there? My answer is 1. What I'm saying is this. In the probability question, if you find for everything, all the events there, if you sum them up, you should have 1. Like in this case here, I have 1 after summing them up. I'm just opening your eyes to all these things. After I solve this question 2, let's do question 3 in the study of probability. It says, if 2 fair coins are flipped, comma, what is the probability of getting at least 1 head? B. If 3 coins are flipped, what is the probability of getting at least 2 tails? C. If 3 coins are flipped, what is the probability of getting exactly 1 tail? Let's solve this question.
Here is a coin. One side is called heads and the other side is called tails. When we toss a coin, either heads or tails can occur.
This question is a coins focused question, right? Now you check there. They said flip 2 coin and flip 3 coin. So in my question there, I'm asked to flip 2 coin and 3 coin. We already established 2 coin. So for 2 coin, for two coin, if I flip two coin, my sample space for two coin gives you head and head, head and tail, tail and head, and tail and tail. This is for two coin. For three coin, for three coins, we already do for three coins before. The sample space for three coin is head, 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 comma, head, head, tail, comma, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. All right, this is the sample space for three coin, right? This is 4, this is 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So the question focus on two coin and three coin. Now, what's question A? Question A says that if it says if if two fair coin are flipped, what is the probability of getting at least one head? So probability of getting one head will be equal to, now before I find the probability of getting one head, I need to find how many one head is there. So for one head, so for one head, now if I check for my flipping two coin, right, one head, at least it must have one head. So this is having one head, one head, one head. So that's more of like saying the one that have one head include H has one, at least one head, H tail has at least one head in it, and tailed head has at least one head in it. So there are three. So the probability of getting one head, the probability of getting one head is equal to the possible outcome of that event, which is one head, and that's what, 3. The possible outcome is 3. Count them, 1, 2, 3. That's 3. All over there, total outcome or the sample space for two coin. What's sample space? That's 1, 2, 3, 4. That's 4. The sample space is 4. So that's 3 over 4. And that will be equal to, if I divide them, that will be equal to 0.75. All right, that's for two coin. That's for question A. Question B says if three coins are flipped, comma, three coins now are flipped, what is the probability of getting at least two tail? So probability of getting at least two tail. So I have to find two tail. So now let's focus on at least two tail. At least two tail, right? What will it be? So for how many coins this? Three coins. Now come down here for three coins. At least it will have two tail. So this one here has two tail, two tails, two tail, two tail, and two tail. So 1, 2, 3, 4 are the outcome for two tail. That's head, tail, tail, head, tail, tail, and next up tail, head, head, tail, head, tail. I have tail, tail, head, and I have tail, tail, tail. All of them here contain at least two tail. Now, it's the probability of getting at least two tail, right, is equal to what? For two tail, what's the possible outcome of two tail? That's 1, 2, 3, 4. That is 4 all over, we said total outcome of sample space. Yeah, we're looking at three coins. For three coins, what's sample space for three coins? That's 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 here. I have 8 here. This gives you 4 here 1, 4 here 2, 1 over 2. And my answer becomes 0.5. That is how you solve for question 2, right? In the study of probability, right? So this is how it works. Let's do question C. Question C. We like this stuff. What question C? Question C is for how many coins? Question C. If three coins, okay, three coins. Question C is three coins. So I will leave this part here. I'll leave this part. You can use this for question C. So question C says, if three coins are flipped, what's the probability of getting exactly one tail? Three coin, one tail. Probability of getting one tail, one tail. Probability of getting one tail, right? Exactly one tail. Now for one tail, let's focus on one tail first. So how many one tail will you see in flipping three coin? For flipping three coin there, all right. So how many one tail? One tail, exactly one tail. Please, they didn't say at least one tail. They say it must be one tail. Will I see this one tail? See, here is one tail. I'm having one tail here. Let me clean this one here. So no confusion. This one here is having exactly one tail. Exactly one tail here. Yes, exactly one tail. Exactly one tail. So we have three possible outcomes. That's head, head, tail, head, tail, head, and tail, head, head. This is exactly one tail. So what's the probability of getting one tail, exactly one tail, please? So the probability of getting exactly one tail is equal to what there? We said is equal to all possible outcome of one tail. 1, 2, 3. That's 3. All over what there? Total outcome of 3 coin. That's what there? That's 8. Right. So divide this one here. 3 divided by 8 gives you about 3 divided by 8. That's 0.375. All right. This is your answer to this question. All right. Yeah. Okay. Next up there, let's do yet question 4 or question 3. No, question 4. Question 4. Let's do another question, please. My camera recording. Okay, that's cool. Still recording. You're on fire. We are on fire. Okay. Last question here, please. Last question here. It says a six-sided die is touched. Question A. What is the probability of getting a 2? Question B. What probability of getting a 3 or 5? Question C. What probability of getting a number that is at most 4? Question D. What's the probability of getting a number that is greater than 3? Question E. What's the probability of getting a number that is less than or equal to 5?
This is a die. A standard die has 6 faces, numbered from 1 to 6. When we roll it, any number from 1 to 6 can occur.
Hold on. Before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of the shortcut to academic success today. Your future self will thank you.
Now, this question focuses on dice, right? So what you should do is this. For every question, it will focus your mind on an object. And we have talked about dice already before now, right? That the sample space for a dice is 6. That a dice has 6 sample space. So, question 4. So sample space here is just 6 because it's a dice. 1, 2, 3, 4, 5, 6. A dice has total of 6 sample space because it has 6 spaces and each of them has 1 to 6. Right? So that's one. Question 1 says, what is the probability of getting a 2? The probability of getting 2 is how many? Check this question, check the sample space. How many 2 do we have here? We have just 1 2. That's 1. Probability of getting 2 is just 1. Yeah. All over what there? All over what? Total outcome. That's 6. All over 6. Divide here. This man gives you about 0.16. Right? That's question A. Done. Question B says, what is probability of getting a 3 or 5? Probability of getting a 3 or 5 will be equal to how many 3 is here? 3 is just 1 3 that is here, right? It's just 1 3. Just 1 3 that is here. How many 5 is here? Just 1 5. So 3 plus. Now, so how many 3 is here? 1 3. So we have 1 plus how many 5 is here? Also 1, right? That's 2. All over 5. 3 is 1. 5 is also 1, right? Okay. So I'm having this, right? All over total outcome, that's 6. Total outcome, that's 6. This one gives you 2 over 6. This one gives you 1 over 3. And that's equal to 0.33. 0.333 continues. Right? So what I'm saying is this. For 3 and 5, they are just 1 1. 3 is 1, 5 is 1. So combine them, that's 2 over what? The total outcome, that's 6. So I solve this, please. Question C. Question C says we have to find question C. Probability of getting at least 4. So probability of getting at least 4. For at least, the least should be 4. For at least 4, it means from 1 to 4. So when we say at least 4, what we mean is 1, 2, 3, 4. This is at least 4. Are we good now? So at least 4 contain 1, 2, 3, 4. Right? So the probability of getting at least 4 will be equal to what there? All possible outcome of at least 4. That's 1, 2, 3, 4. That's 4. All over what there? Total outcome. That's 6. So this one gives you 2 here 2, 2 here 3. That's 3 over 2. So 2 here gives you 2. 2 here gives you 3. That's 2 over 3. Sorry. If I divide 2 over 3, I'll have about 0.667. That's your answer to that, please. Question D says probability of getting greater than 3. Probability of getting greater than 3. For greater than 3, that's 4 to 6. So when we say greater than 3, greater than 3, it means from 4, 5, and 6. This is what we express as greater than 3. But when we say greater than or equal to 3, it means we must include 3 in the list, right? So the probability of getting greater than 3, than 3 will be what? Will be 1 to 3. That's 3 over total outcome is 6. So 3 here, 1, 3 here is 2. So 1 over 2. This one gives you 0.5. 0.5. Yeah. The last one, E, says probability of getting less than or equal to 5. For less than or equal to 5 means 1 to 5, right? So let me do it here. Probability of getting um, less than or equal to 5 means from 1 to 5. So 1 to 5 is the range of less than or equal to 5. So that gives you 1, 2, 3, 4, 5. That gives you 5 over total outcome is what? Is 6. And this man gives you about 0.83. Alright. For less than or equal to 5 means 1 to 5. That's the meaning. So the probability becomes how many are they? 1, 2, 3, 4, 5. That's 5 over 6. So you have this as your answer. This is how you solve problems in the study of probability. In our next class, we will look at probability formula, symbols, notation, right, such as marginal probability, union probability, joint probability, negation probability, right. We'll also look at conditional probability. Also, we'll look at addition rule, version rule in probability in our next class. See you in the next class. Also, I want to remind you all, if you have at least some money with you as a student, you can support us by, we need more ink for teaching, right? We need more markers, right? I think this is the last marker I have here with me. So we need more markers, more ink, and more resources. So if you have a couple of money with you to spare, you can reach out to us by assisting us, please, through this journey of teaching people globally, right? So do well to assist. If you're interested, reach out to me. My WhatsApp number I'll display that you're interested in assisting. Then you donate all the money we compile together to get all this stuff ready and to make sure we give you guys standard education. Welcome to Excellent Link Academy. This is the first time here. Do well to follow my page, subscribe on the channel, leave a comment, and share the video to your friends and classmates so they can also learn. Also, don't be selfish. Do leave a comment. Like if you leave a comment, it gives the algorithm, the YouTube platform to push my video more further. If you watch it and just leave it, they'll think you don't like, people don't like it. So like it, share it, leave a comment. I'm supposed to be global, but look at me, look at my views and my followers. We're not much. This knowledge are meant to be shared globally. So just be a blessing to me. Share this video. I can't do it alone, right? I can't do it alone. So see you guys at the top, right? And welcome to Excellent Link Academy.